Hey, I can help.
How can you help?
We just have to change the angle on the catapult.
How will changing the angle do anything?
Well, just imagine the tennis ball as an object in a graph. Now there's two forces acting on it, right? The force of gravity, which pushes it down, and the force of air resistance, which slows the ball during the flight. Now in our scenario, the force of air resistance is negligible. So this kind of motion is called projectile motion.
How do those forces interact?
Well, basically, when you apply the force to the ball from the cannon, you have to apply enough horizontal force so that it will be moving fast enough and enough vertical force so that it will counteract the force of gravity long enough to stay in the air for a good amount of time. This will maximize your range.
How does the angle of launch come into play?
Well, the catapult is what's applying the initial force to the ball, right?
So the angle of launch affects how much of your force is applied horizontally and vertically. If you think about it, if you launch perfectly vertically, you'll have no horizontal force, so the ball will go straight up and then come right back down. Now similarly, if we launch perfectly horizontally, the ball will have no force to counteract the force of gravity and it'll hit the ground almost immediately. So how do we find that perfect angle to have enough force in each direction?
Well, if we need both horizontal and vertical force to make the ball move, wouldn't we want somewhere in between the two?
That's right. We actually want right in the middle of the two, at 45 degrees. That's guaranteed to give us our highest total range possible.
Here, let me show you! This is the equation for finding range using velocity and angle. The force of gravity is equal to a downwards acceleration of 9.8 meters per second squared. And obviously, the faster the projectile is moving initially, the further it will go. So for right now, let's just make up a speed, say 10 meters per second. So when we solve for the first half, we get 20.40816. So now the question is, how do we make the second half as large as possible? Well, since sine and cosine are essentially opposites, when we put in 90 degrees, sine will be its maximum, but cosine will be 0. Similarly, when we put in 0 degrees, cosine will be 1, but sine will be 0. So when we put in 45 degrees, right between the two, we get 0.707 for both, giving us the highest possible product of 0.5. Let's try it out in real life.
We get 45?
Yeah.